Welcome back. Hononegah Honors, Algebra 2. We're going to go into 4.8, Analyzing Graphs of Polynomial Functions. This is not to say that a lot of this chapter isn't graph and calculator oriented, but this one really is graph and calculator oriented. So you really need to go step by step as we're going through this and hopefully get an understanding of what the calculator is doing for you. So we've learned about zeros, factors, solutions, and x-intercepts. Here is the summary of what we've talked about. So if I say something is a zero, that means, let's say a number like 3 is a zero. So you'd put 3. That means the factor is x minus 3, the solution is x equals 3, and the intercept is at the point 3, 0. So again, every single one of these is just a slight bit difference, but not much different. So when they ask you for a factor, they're asking for a parenthesis. If you're asking for a solution, they want to know what x or the variable equals. The number is actually the 0, and then the intercept is the point. Now, going through this, again, I want to pull out a graphing calculator. I want to be able to graph this, and you can use basically an XY chart or to transfer information over from the graphing calculator, but I do know some points here just by looking at it, because 2, if I put 2 into that one, it makes the parentheses 0. And if I put -3, it makes the second parentheses 0. So again, I already know some points for this, but I am going to switch over to the graphing calculator. So the graphing calculator, I went ahead and typed it in for you. And so 1/4 parentheses x minus 2 parentheses x minus 3 quantity squared. So I'm going to hit graph. And the graph's going to, my window was off, so I fixed that. So the graphing calculator, notice it has a little zigzag there. I already know that it's crossing at 2, and it's also touching at 3. So it's not really showing much of a picture there. But here's what it basically, I'm going to go to second graph, and there's some points that I can do. And so notice 1, -1 is a nice point, and 2, 0 is a nice point. And as I go down here, notice that it goes slightly over the graph and then it touches at 3, 0. So going back to I can see at 1, -1 was a nice point, and 2, 0, and 3. So it goes up, goes across just barely, it touches, and then goes up. And now this is, again, it's not a great picture or a great analysis here, but ultimately you can graph these functions using points that the graphing calculator would give you. The next one is a little bit nicer, and we're going to talk a lot about this one because we're really going to need the graphing calculator on this. Another important characteristics of graphs and polynomial functions is that it turns, corresponding to the local maximum and minimum. And so basically, when you have a graph and it's going one direction and then it turns and goes another direction and it turns and goes another direction, those are referred to as local maximum and minimums. Kind of like having a vertex, but it's having a local vertex, like a vertex in that area. And then a local minimum, meaning a bottom in that area. And we also notice we're back to talking about increasing and decreasing. So going from left to right, again, looking at this like a roller coaster, this would be the increasing, this would be the decreasing, and then we're back to increasing again. And so we're back to those interval notations. And everything starts at -infinity on the left-hand side and ends with positive infinity on the right-hand side. And it's always the x values when we're doing our intervals. So again, one of them is going to start off with -infinity, and one of them is going to end with positive infinity as we go through this from left to right. So we always start off at the left and always end at the right. So let's go through one. This is going to be a little challenging, and again, we're going to need our graphing calculator. The y-coordinate of the turning point is the local max of the function. The y-coordinate of the turning point is the local min. Now, those turning points of the graph help determine the intervals for which the function is decreasing, increasing. I know some of you are saying, wait a minute, you said x values. The actual max is the y. the interval notation is going to be the x. So I don't mean to confuse you there, but if it asks you what is the local maximum value, you're talking about the y value of the point. If you're actually going to be doing the interval, now you're talking about the x value of the point. So again, don't mean to confuse you. Now, how do I know how many turns there's going to be? If it's let's say it's a cubic, which has a degree of 3, I know there's going to be 2 turns. So a cubic is going to look like this, and there's 1 turn, 2 turns. So again, it's always the degree minus 1 is how many turning points there's going to be when looking at a graph. So here we go. Graph each function, identify the x-intercepts, and the points where the local maximum and local minimums occur. Determine the interval for which the function is increasing and decreasing. There's a lot of information here. So a lot of information here again. I need to go to my graphing calculator. I need to type this in. And I've already typed it in, so when we go to the next screen, you might have to hit pause for a second. But there it is. I typed it into my graphing calculator. So x cubed minus 2x squared plus x minus 2. And I'm going to hit graph just to give me a little bit of a picture. And notice that it goes up, it kind of goes down a little bit. So that's a real slight turning point, and then it goes up again, so that's another turning point. And if you want to, a lot of times you can zoom in. And if I ever want to zoom in, I usually always go like zoom box. And what a zoom box does, it basically allows you to make a box. So I'm going to hit enter, and then as you go down and as you go across, you actually can zoom in on just that little picture. So that allows you then to get a better idea of, look, it's going up, it's going down. There's a slight up and a slight down there. So now, I want to graph this. So I want to hit second graph, and I want to get some points to graph. So notice again, my interval, my notation here is going by 0.25, or my XY chart is going by 0.25, but this will give me an idea, like 1, -2 would be a good point, and 2, 0 would be a good point. So if I go back to my picture, I have 1, -2 as a point, and 2, 0 as a point, and 0, -2 as a point. And then -1, I'd have to go back to my, so if I go to -1, 0, -2, -1, -6. So again, I'm trying to get some points here to graph. So it goes up, it goes down, and it goes up again. So there it is. And all I did was take points off the graphing calculator. Now, when is it crossing the x-axis? Well, I saw that it was crossing at +2, 0. So when I ask for the x-intercept, that's what I'm looking for, is where does it cross the x-axis? And this one's nice, and not all of them are going to be nice. I'm going to be honest with you. The one on the test is pretty rough. Now, I want to know local maximums, local minimums, and then determine my intervals. So graphing calculator now. Let's start with local maximum and local minimums. So on my graph, and remember I zoomed in, I want to hit second, calculate a max. And again, they want left bound and right bound. What that means is you add an arrow to the left of where you think the max is and hit enter, and then you got an arrow to the right of where you think the max is and hit enter. So look, I went on either side of that particular curve, that little, and I hit enter. Then I'm going to, so 0.33, okay, rounding to 2 decimal places, and -1.85. So I'm going to go back to my screen and I'm going to write that down. I got a max at 0.33, -1.85. Okay. Next, I want to find the minimum. So I'm going to hit second, trace, and I'm going to go to number 3, and that's a minimum. And again, I want to go to the left of the minimum and to the right of the minimum. So I hit enter on the left-hand side. I see it's going down, and then it starts going back up. So I'm going to hit enter on the right-hand side. So I want to know where the minimum, the local minimum is in between those two spots. And so I hit enter, and I'm going to round to 2 decimal places. So 0.999, so that's 1, -2. So going back, I have a local min at 1, -2. So now, how's this going to work? Well, this is going increasing. This little spot down here, it switches over to decreasing, and then over here, it's back to increasing again. So starting from left to right, I go negative infinity till I get to that max of 0.33. And then my decreasing goes from 0.33 to 1. Notice all of these are using the x's. And my increasing goes from 1 to positive infinity. So as I said, there's always going to be one that has a negative infinity in the beginning and one that has a positive infinity at the end. So this is increasing, decreasing, and increasing again. Those are my answers. I've got all of them from a graphing calculator. So let's do another one of these now that we've kind of seen this. And there's a lot to be done on the graphing calculator. This is a very complicated question. All right, so this one, as said, I hit pause there for a second, but this one's a little more complicated. X to the fourth minus 5x cubed plus 2x squared plus 8x minus 2. I want to identify the x-intercepts, the points where the local maximum and minimums occur, and then I also want to do the interval. So there's kind of 3 parts to this. Where does it cross the x-axis at? Where are the turning points? And then where's the interval when it's increasing and decreasing? So moving over to the graphing calculator, and again, I've already typed it in, so you're going to need to hit pause. And then I'm going to hit graph. So I can see that it crosses in a number of locations here. So I need all 4 of those points. Like I want to know where each one of those is. And so I'm going to hit second in table so that I can try to get at least some points where it's crossing. And I see 1 right there, but -2, 46, that doesn't help me much. -1, 2, -2. So I'm going to go over here to my graph and start doing that. 0, -2. So -1, -2, I think was an option. Sorry, I'm going to go back and forth here. I didn't do -2, positive 46, 0, -2. So I have back to back there. What about 1? So if I arrow down here, where does 1 hit? 1, 4, 2, -2. So I'm going to again start graphing those. 1, 4, 2, -2. What about 3? 3, -14. 4, -2. So again, that kind of gives me a picture. And so it goes down, it goes up, it goes down, all the way down here to 14 and back up again. So all I want is some basic points of where this picture is being located. All right, so now x-intercepts on the test, and this one is literally just like the one on the test. I need to find the 4 points that it is crossing the x-axis. So again, I can see just in the picture that there's 4 points that I'm going to have to come up with. So there's a lot of stuff that I'm going to have to do on the graphing calculator to get those 4 points. Switching back. All right, so here we go. I'm going to go to my graph. So hit second and graph. And I want to look for each one of these. So I'm going to need to hit second, calculate, and I've got to do a 0. And I'm going to have to do a 0 for each one of these. So number 2 here. Left bound and right bound. So I need to be the left of the 0. So notice I hit the left arrow and hit enter. And then I need to be the right of the 0. So as soon as it goes across, I want to know where it crossed at. And I'm going to hit enter there. So negative 1.110. So I got to write that down. Negative 1.110 is the first one. Back to the graphing calculator now. Hit second, trace, 0. And again, anytime you are left of a 0, hit enter, and then you arrow to the right so you're on the other side of the axis and hit enter again. So it's going to tell you where it crossed in between those two lines. 0.240. So I got to write that down. 0.240. We're going to keep going now. Second, trace, 0. Basically, I'm just going through each and single one of these. So I'm going to go enter when it's above and enter when it's below. And then I'm going to hit enter again, and it's going to tell me the 0. So 1.820. 1.820. And the last one on my graphing calculator. Hit second, trace, 0. So now hit enter when it's below, arrow to the right, enter when it's above, and it's going to give you the 0 in between. So 4.05, rounding to the nearest hundredth. Now, don't concern yourself. That's actually scientific notation. For some reason, the calculator isn't exactly at 0 because it's infinitesimally off, but 4.050. So write that down. So there, I was able to come up with 4 times where it crosses the x-axis. Now, I have to identify local maxes and local mins. Remember, these are the turning points, the points in the graph. So I'm going to have one right here as a local min, one up here as a local max, and one down here as a local min. So I'm going to have 2 mins and 1 max. Go back to my graphing calculator. This time I'm going to hit second, trace, and this time I'm looking for a minimum, so number 3. So I got to get all the way to the left of the minimum. So I'm going to go way over here, my cursor, until I get, there it is. So now I am to the left. I'm going to hit enter. I'm going to arrow to the right and hit enter, and then enter one more time. So there's going to be the minimum point, and again, 2 decimal places, so negative 0.57, negative 4.88. So go back and write that down. This is a min, negative 0.57 and negative 4.88. I hope that I wrote that one down right. Yes, negative 0.57, negative 4.88. So there's one minimum point. Now let's go back to the calculator. Hit second, trace. This time I'm going to do a maximum. So I've got to be to the left of the max point and hit enter. And then I got to arrow to the right of the max point and hit enter. And then hit enter one more time. And so that 1.07, 4.04. So that's a max. 1.07, 4.04 is a max point. Back to my graphing calculator now. I want one more. I need another minimum. So I'm going to go to number 3 here. And again, as long as you're to the left of the minimum and you hit enter, and then arrow to the right, and as long as you're to the right of the minimum and hit enter, it will give you the minimum point in between. So hit enter again. 3.25, negative 14.95. So 3.25, negative 14.95. So there's my local maximums and minimums off the calculator. Now for the really, really, really hard part. I got to identify when it's increasing and when it's decreasing. So left to right, this part's decreasing. This one's increasing. This one's decreasing. This one's back to increasing again. So I have 2 decreasing intervals and 2 increasing intervals. You're using the x values. So now increasing, decreasing. So I start off with negative infinity and I'm decreasing until I get to negative 0.57. So notice that is the local min at that particular location. Then at negative 0.57, it's increasing until it gets to 1.07. That's the next max. And then at 1.07 to the next point, which is 3.25, it's decreasing. And then from 3.25 to infinity, it's increasing. So I'm going to explain that one more time as it's going across here, but that is the correct answer. So now it's decreasing. Oh, here's it starting at negative infinity, and it's decreasing until it gets to the point at the bottom there, negative 0.57, negative 4.88. Then it's increasing till it gets to the next point. So negative 0.57 to 1.07. Then from 1.07 to the next point, it's back to decreasing again. So from from positive 1.07 to 3.25. And then from 3.25 back to positive infinity, it's increasing again. This question will be on your test. It takes a while. It is time consuming. So hopefully you'll be able to get this one when you have it. Last concept we have for today is actually a pretty easy one. It's talking about even versus odd. And it doesn't mean just an even power or an odd power. It means when it's symmetrical about the y-axis, it's actually considered an even function. And when it's symmetrical around the origin, it's actually considered an odd function. So not all x to the fourth graphs are even functions, and not all x to the thirds would be considered an odd function. Here's how you actually do this, is when you plug in a negative x for all the x's, all the x variables. If you end up getting the exact same function, okay, then it's actually considered an even function. If you put negative x in for all the x's and everything has been changed, notice all the x's and all the y's have been changed, then you'll actually have an odd function. So here we go. I'm going to put negative x in for all the x's. So negative x to the third minus 12 to the negative x. Well, negative x to the third power is negative x to the third, and negative 12 times negative x is positive 12x. So now look at your new function and look at your old function. And if everything has been changed, meaning the signs have been changed, this is considered an odd function. So what happens if I put negative x in for all the x's? And so negative x to the fourth power is a positive x to the fourth. Negative x to the second power is positive x squared minus 7. So look at your new function and look at your old function. And if it's exactly the same, this is actually an even function. So now negative x in for all the x's. Negative x to the fifth is negative x raised to the fifth power would be negative x to the fifth. And this one didn't have an x. So now look at your new function, look at your old function. Yes, the negative x to the fifth changed, but the positive 9 did not change. So this is actually considered a neither. It is not an even or an odd function because it is not the same and it doesn't change all the signs. Your homework assignment is out of the book. Again, some of those questions can be challenging using a graphing calculator. If you have questions with your graphing calculator, you really need to talk to your teacher so that you understand it. And good luck.